Hello everyone, welcome again to the Modern C++ course. Today we're going to do a very short tutorial talking about OpenCV. OpenCV is a widely used library for image processing. It's supported by a lot of companies and researchers, and it's not about the concepts that it covers, but rather you should think about OpenCV as a tool. So you shouldn't say I know OpenCV, but rather know how to use OpenCV, because it does not involve any concept. So we are going to use the version 4 of the library because it's the one fully supported by C++11 compilers and is more like a C++ style library. So we are going to talk only about the small part of it, how to build some basic examples, but we will cover just a very small portion of it. To use the library, you should include OpenCV2 and then whatever you need. In this case, this covers all the functionalities of OpenCV. And the namespace is cv::, and you can find more in their webpage. So OpenCV uses their own types and it trusts you to use the correct types. So we'll talk about this later, but it trusts the user into saying that, okay, you should know which types you are using, and when you ask for something and you specify it's a float, I will trust you that it's actually a float and it was not an integer, for example. So the types in OpenCV are usually this CV prefix, then a bit count, which is basically how many bits the type will contain, then an identifier and the number of channels. So we can basically see this example in which we have an RGB image, which CV, the prefix, then 8 bits for this unsigned character type, and then 3 channels. In this case, this will mean that we will have basically the same structure 3 times, one for each RGB channel. The same is in grayscale, but in this case we need only one channel because it's for the intensity. And you can use data type instead of using this not very friendly syntax. You may use this data type, which helps you to work with it. So the most important type in OpenCV is this CV mat, which is the matrix. And the way on creating matrices is, okay, specifying the type, which is CV mat, then the name of the variable as always, and the rows, the columns, the data type, and the value. So if you want to instead, so you can also use the templated version, the templated type, in which you provide the type here, and then rows, columns, and value. For example, in this case, we are going to create a matrix of zeros. So we are just creating a CV mat. So we are specifying, okay, we are going to create the CV matrix, which is called image, and we'll populate. So in this case, we're creating a matrix of zeros. This is a function created, and we say the amount of rows, columns, and the data type. And for example, if we don't want to use all the time CV mat float, we can use this as an alias, and every time we call matf, we will actually be creating, as we mentioned before in other lectures, we'll create a variable of this previously declared type. And this will save us, so the code will be much easier to read, and this will save us a lot of space. We can get the type of identifier using the function type, and we can get the size basically by accessing how many rows and how many columns this matrix has. The most common functions that you will use are to read, emread, emWrite to write, and emShow. So something that you should be aware of is that the CV mat is implemented as somehow a shared pointer that we will cover in following lectures. But the most important thing is, for example, here we are creating this image, which is a matrix of zeros. And whenever we use the assignment operation, we are not copying, as we say here. So here, this image no copy is not a copy of image, but rather we are doing reference to the same instance. So whenever you can try, the idea is that you try this example locally, and you will see that actually when you modify this image no copy, you are also modifying the original variable, the original image. So This can lead to a lot of headaches if you are not aware that you are not copying with assignment operator. So if you want to copy, you have to use image.clone. In this case, you will generate a copy of the image. So again, you should try this example. And the takeaway is don't use assignment operation as a copy. So it will not copy anything. The first function we'll cover is the how to read images, which is the syntax is quite easy. So we have to provide the file name and the mode, which is basically these are aliases for integers. And we can say, okay, I want unchanged, so just give me the image. I want it in grayscale, or I want it in color, let's say. So for example, again, these are all examples that you can try whenever you have, so you have to provide this image. Okay, but we will say, okay, give me this image in grayscale. And or for example, this other image, I mean the same one, we can also assign to, so in this case, we are just creating a matrix. Here we are creating a matrix specifying that we want it to be uint 8 of the data type. So to write an image is again a very similar syntax. We specify the file name and then what we want to write, so the matrix. That has to be a CVMAT matrix. So here we first read, for example, this image in grayscale, and then we just call write, em write with this string, with this file name, and then the image, which is this matrix that we have created here. So whenever we are working with float images, we have to be aware that, okay, here, if we use PNG as an extension, then we will have, we will lose precision. So if you don't want to lose precision, you should use these EXR files, so the extension, and I think here you have an example. And yeah, if you run this and you try with PNG instead of EXR, you will see that when you load the image, you are actually getting something different because you are losing precision. So you should try this example, but yeah, it's only when you're working with float images or float matrices. How you will show your results in the display is using the emShow function, which again, it receives a window name that we have to create and a matrix. So here, if you follow the code, we are creating, so we are reading an image and populating this image variable, which is a matrix. Then we created a named window with this function, which has this name, and this way we can say OpenCV that it should choose the size of the window that we are going to create, where we are going to display our image or show our image. Then we use the function and we specify, okay, the name of the window, which is window space name, and the image. And after showing, so this will just show the image, and if we don't have this line here, it will just close the image instantly. So what we have to do, this function, what does is allows us to wait until we press a key. So if we include this, we will say, okay, whenever a key is pressed, we'll close the window, but otherwise the window should remain there so we can actually see the image. When we want to use vectors of pixels, for example, we can use this vector type that OpenCV also provides, in which we have to specify the type. There are already some aliases or type defs to, if you want to work with floats, for example. And in this case, for example, as to show you, we are creating a matrix, and then we are now creating a matrix of vectors. So every entry will be, in this case, a vector of 3 floats. So this is to work with multi-dimensional images. Again, as I mentioned before, OpenCV trusts you that you will pick the type. So this can cause errors because let's say that we are writing an object which is only one element, which is 2 bytes, for example, 1 float. And then when we read that matrix, so we store a matrix with only 1 element, which is a float, so 2 bytes. When we read it, if we say to OpenCV, okay, give me the content of this matrix, which are, for example, we want to reinterpret this, it's similar, so we say read this element, which is a character. So it will give us actually 2 elements, because it will say, okay, this matrix is 2 bytes, so you say that I should give you characters or 1 byte at the time, so it will give you 2 elements. So you have to make sure that you are using the correct types, because again, OpenCV trusts you to pick the type. This is an example that you can try, but the important thing to show here is that when we are creating this image, in this case we are saying, okay, we are going to create the type of this image is, as we mentioned before, this is the OpenCV type, which is basically 8-bit, so it will be an unsigned char. So this is the important part, 8 bits. And whenever we want to access, so this image.add function will allow us to access in the row and column that we want to. So if you try this, you will see the behavior. But let's say that we want the element 0, 0, and when we say float, so in this case we are assigning a float, and actually this 0, 0 element is not a float. The float is 2 bytes, and here we are saying that we are using unsigned chars. So we are going to assign something which is 2 bytes to this position, but OpenCV will not throw any error because it trusts you to choose the right type. So you should be aware that if you are declaring here that it's 1 byte, then you should also assign something that is 1 byte. Otherwise, OpenCV again will not complain, but you are using the wrong type. So this is something that we are not going to explain. This is something that you need for your final project, but OpenCV also provides you an implementation to use SIFT features, which are very, very popular features because they are illumination, rotation, and translation invariant. And OpenCV provides you a way of using them. So here is we keep this here so you can check how to use it, but it's very straightforward. So we first create the SIFT feature detector, then we create a vector of key points, and this way we access. So we say detector, detect. This is the notation. We will show this later in other lectures, but for now you just have to know that we use a detector, we call the function detect, we pass the input, which will be the input image from which we want to get the detectors, and then the key points, and then this will populate this variable. If we want to show the key points, we have to create an image with key points. So again, we in this case create the matrix that we will populate, and then we use this draw key points function. We specify the input, then the key points. So the input will be the image, the key points that we extracted before, and then we will say where to put this result. So this image with key points will be the image with the key points showed in that image. If we want to extract the descriptors from the image, we need to again create an extractor using this SIFT descriptor extractor, and then we will use, as before, just a function, which is in this case compute, which will receive the input image, the key points, and will populate the descriptors variable that we also have to pass. We just have to create it, and then in the end we'll have the descriptors populated in that variable. Again, here we are not covering what SIFT is itself, but rather we are showing you how to use OpenCV to get the key points. So something that you will use in your homework assignments is FLANN, which is to build a KD tree and search for neighbors. So here you have somehow how to do it. So whenever you have to use it, you can come here, and yeah, first you have to create the KD tree, and then you have to use it. You can use this KNN search to search the nearest neighbors, and you can specify how many neighbors you want, but that's basically something that you will learn by using. So this is just here so you don't lose time checking around how to use it, but rather go to the slides and check it here. So when we are basically using OpenCV, we have to first install it. In this case, so in this website, we have examples of OpenCV that you can download. So in this sense, you can check if your installation is correct. So you install it and then you build these examples. There is also a tutorial or a guide how to install OpenCV, but basically we are downloading it and compiling it from source. Once you have that installed in your system, in your CMake, you have to use this line. In this case, so to find the package, to find the library, we want OpenCV, we want the version 4, and it's required. So if we somehow have not installed this library, since it's required, it will fail. It will say that CMake cannot find this library, and then it will fail. It will not allow you to later compile. Then the directories we have to include are in this variable, and we have to link against this. So for example, if we want to link a library with the files, we will target link libraries, and we specify, okay, the library and what we want to link against. And if we want to link with an executable, we say, okay, this executable link with these libraries. This is mainly what we wanted to show you about OpenCV. Again, it's just a small part of the library and how to use it, how to compile it. You can find in this example that we provide you, but if you already have in your library installed, you can also link it as we showed in the previous slide. Now we are going to show how to run a small hello world example with OpenCV. So let's start in this directory in which we only have one image. We will first create a CMake list file and touch a main file. So here we'll start with the main file. So including, let's close this, include IOStream, and then just int main, and just hello world. And let's open now the CMake list file. So we will say that we want the minimum required version will be 3.1. Our project will be just example. And yeah, just to let C code help us with the autocomplete, search, export, compile commands on. Yeah, and then just add executable main.cpp. So this way we should be able to do CMake here and then make. Okay, now we have our executable, and if we run it, we get hello world. So let's now add OpenCV into the game. So we're going to include OpenCV. So here include OpenCV. We will, as mentioned before in the slide, we will find package. We'll say we want OpenCV version 4, and this is required. So as I was mentioned before, if we set this required flag, then the CMake will throw an error if it cannot find this library. So for example, OpenCV, it will find it because we have it installed. But if I say, okay, find this OpenCV A library, whenever I do CMake, it will say that it cannot find this OpenCV A library. So instead, I would just say here OpenCV, and you can say that if I do CMake now, it say found OpenCV in this folder, and this is the version, the minimum is 4. Okay, then we want to include the directory, so include directories, and as shown in the slides, we have to specify OpenCV include dirs, and then let's say that we want to link it. So far we are not doing anything with OpenCV, but we want to set everything to work with it. So target link libraries, and we will say, okay, link the main application with this OpenCV libs. Then now we can come here and we say CMake, and everything's okay. So far we are not linking anything. Now it will, so first compile and then link the main with OpenCV. So let's go again to our main application. So we're going to what we're going to do is we're going to create a CV mat, like this. So let's first, okay, here include OpenCV2 / OpenCV.hpp. So we include everything. Now we are going to create the matrix, so CVMat, and we are going to specify here the name of our variable, which will be image, and we will just open an image, so emread, and then say lena.png. And again, we have to say how do we want to read the image. In this case, it's CV emread grayscale. So let's see if now CMake helps us with autocomplete. So let's reload this. Okay, oop, it's not helping. So let's see, CMake, yeah, here. I always forget, yeah. So CMake, the CMake export compile commands on here. Yeah, now it's helping us. ClankD is helping us with the autocomplete. So we will now, this is something you should get used to do, which is check if you are actually reading something. So you check if your image is empty or if you are actually reading something. Sometimes you are building a very long pipeline and then at the end something's not working and you wonder why, and in the end what's happening is that you are not loading any image. So this is a good practice. So we just say to the standard error, file not found, and they will just return 1. Here I forgot to return 0 to say that everything was executed successfully. So now we want to show this image. So we will create a named window, and we will say this, the name of this window will be just window, which is, in this example, is just more than enough. And then we will say, okay, show the image. So with em show in the window called window, and the image we want to show is image. Again, if we want to run this, the image will be shown and the window will be closed again because we don't have any delay or anything. So what we are going to do now is to add here CV wait key, and we can specify a delay. In this case, we will say 0. So this will, again, let's go through the code. This will print hello world. Let's print something different. Let's print hello OpenCV. This will read the lena.png file that I have in this folder. So this file, it will read it in grayscale. Then we'll check if the image is empty, and then we create a window. Sorry, here we forgot that we have to specify the size. So it's window auto size, perfect. And then we are going to show our image that we read, which is this lena.png image. So let's compile this. So CMake, and then make. So this is building. Compiling our program, which is just an executable, and then linking. So now when we execute the command, we are basically open this window. If you want to check, if we remove this image and we run now this main.cpp, this main, we are not finding the image, so we throw in an error. So I hope this tutorial was helpful. This is at least a way of generating a small project and linking with OpenCV. I hope you enjoyed it, and thank you for your attention.